class, write in standard form. So I'm going to start by distributing these two. So my first step to get to standard form is distribute the x. So I now have y equals x squared plus x. And then can I write x minus 2 as two binomials? X minus 2 squared is x minus 2 times x minus 2. Now from there, do you see I have to do some foiling? I'm going to choose to FOIL these two first. Got it? I'm going to choose these two first and then bring this guy in second. So as I FOIL this, I'm going to multiply this through. So I now have y equals, I still have the x squared plus x. And as I FOIL this, x times x is x squared. Now hopefully you can see as I multiply this times this and this times this, won't that be a negative 4x? I'm combining them right away, so this is a negative 4x. And the negative 2 times negative 2 is a positive 4. So I did group these two, this multiply and this multiply together right in my head. So now I FOILed this, I distributed the first, now I got to FOIL these. I like the box. When you have a 2 by a 3, the box tends to be a little bit cleaner. And here's what I mean by the box. Okay, don't write too big because you need some space, because later on we're going to put a graph in this. So which one's going to be on the left? You have x squared plus x. What's going to be on the top is going to be the x squared minus 4x plus 4. Now, can we use this like a multiplication table, meaning x squared times x squared times negative 4x, and fill in the boxes? Do you understand we're going to get 6 terms, but will some of them combine? We're going to get 6 terms. Some of them will combine, and then we put it in standard form. So here we go. X squared times x squared is x to the 4th. X squared times negative 4x is negative 4x to the 3rd. X squared times 4 is 4x squared. Okay, x times x squared is x cubed. X times negative 4x is negative 4x squared. And the last one, x times 4, is 4x. Do any of the 6 terms combine? Yeah. Have you noticed when you do this box, they combine diagonally a lot of times? Not always, but those tend to be the combiners. So don't these combine? And, oh, when the x squareds combine, don't they cancel? Do you see when I combine these, don't they actually just cancel each other out? So we end up with, is we get y equals, what's my highest power? Because we start with the highest power of these. We got x to the 4th. And when I combine my cubes, x cubes, what's a 1 and a negative 4? That negative 3x cubed. X squareds are gone, so that term disappeared. But I still got the 4x at the end, positive 4x. So that simplified down to 3 terms. What degree is this? It is a 4th degree polynomial. It has 3 terms. If I factored this, I'd go back to there. This format, standard form, is pretty useless for graphing purposes. This is very powerful for graphing purposes. Now, if I want to factor this, did you notice a GCF? So your GCF, hopefully you noticed, is negative 2x. That's your GCF. You could actually pull x out as well. So now we got to think of what's left. negative 2x times what is negative 2x cubed? Can you tell it's x squared? Next. What's negative 2x times what gives you negative 4x squared? Can you tell that would be positive 2x? And then negative 2x times what gives you positive 6x? Minus 3. Now, do you see it factoring? Can you see that factoring? What are my sides? 3 and negative 1. So I now have y equals, I got the negative 2x. And what do I have in those parentheses? You have an x plus 3 and an x minus 1. Now, from there, could you graph this?
Yes, you would have to make the negative.
My third degree polynomial, does it actually have 3 zeros? Yeah, I have a 0 of 0, negative 3, and 1. And we're going to graph these in a little bit. Now, if I want to sketch this graph, it's in factored form. Okay. Well, we have to first find our zeros. And do you notice there are 3 zeros? One of them is at 0, because that makes 0. What would make this 0? Can you tell that's negative 1? And what would make this 0? Hopefully you can tell that's 2. So what we're going to do is make a set of axes. Just kind of squeeze it in. All right. And make a couple dashes. They're not perfect graphs. These are just going to be sketches. And we said the first 0 is actually at 0. The second one we said was at negative 1. And the last one was at positive 2. So what you're going to notice is, again, is it 0, negative 1, and positive 2. That's where the zeros are. Now, do you guys also remember when you have a squared, it's going to do something kind of different? I'll describe it to you in a second here once I show the picture. But look at the final answer. Do you see how this is a 4th degree polynomial? Do you see your a value is positive? So 4th degree polynomials kind of look like a happy parabola. If you have an even degree polynomial, they look like parabolas, either happy or sad. Except in this situation, they look like m's and w's. If it's an odd degree polynomial like this one, it looks like a disco dancer. All right, you'll see in a second. So we know this is going to be a 4th degree. It's positive, so I know it looks like a little W looking. Because the W looks like an upward parabola-ish. Okay. If there was a negative in front, it would look like an M. So how do I make a W through these 3 dots? Here's what it's going to look like. It's going to come down. It's going to hit. It's going to come down and hit right there and go back up. Something like that. We don't care about how high or low they go at this point. All I care is kind of about what they look like through the dots. Positive, even power is a parabola-looking W. Now, the reason it just hit off that did not, and it kind of looks like it went below, but are you okay? I hit that and went back up. Whenever you have something squared, it's going to hit it and return, kind of like a bounce off. Where do you see how these two went through? Normal zeros, you go through the 0. But when it's squared, think of it as bouncing off. Okay? So that's important to know. Otherwise, you would never be able to make this W shape. You would think it's the disco dancer look. All right, let's look what this one might look like. So for this problem, do we have this factored form? We look up here. It's a third degree, so this is the disco dancer kind of idea, and it's a negative a value. So are you okay? A negative means kind of downhill. So we'll show you what that's going to look like. It's going to look like that disco dancing kind of thing downhill. What do we mean by disco dancing? It looks like this. Like that. See, it's downhill. This graph will look something like this. It's going woohoo up and down, and it's going down. A positive in front a value would be going up. Okay, let's mark our zeros. Our first 0 is 0. Because, is that okay right here? The negative 2x. What would make that 0 is 0. What makes this 0 is negative 3, and that would be a positive 1. So let's put a negative 3 and a positive 1. Are there any squareds? Are there any squareds on this? No, so there's no ricochet. All the zeros are going to be, it's going to go through. There's no ricocheting, it's just going straight through. And can you draw a shape that looks like this through those 3 blue dots? Hopefully you can kind of tell, oh, it'll look something like this. That is what it would look something like. With the zeros, I know it's a negative third degree polynomial, negative a, so it looks something like that. If that was a positive 2 there, it would go up like this and go up.